what core capabilities does this reference design offer, especially around rapid provisioning, composability, and you mentioned interoperable GPUs, networking, and of course security?
I think everybody at this point knows how to build a private or public cloud, right? You kind of know what the whole system looks like. I don't think as many people have experience with what supercomputing systems look like. And one of the things that's very different, which Shaun was basically alluding to earlier, is you're moving towards a model where you're aggregating systems together and trying to make them look like a single system. So you're trying to take 8, 16, 24, 32 GPUs and put them together for a single system, but it looks like one single GPU, one single set of contiguous memory. You're trying to wire it all together. It's very different from the scale out model. As Shaun was saying, it's kind of more like mainframes. It's more like supercomputing in the past. And so when you're trying to put all these systems together and make them look like one, you run into very specific kinds of challenges around storage, networking, how the systems work, rack locality, whether things are close together. You have to use different kinds of schedulers. You have to use things like Slurm and Slinky, kind of classic supercomputing schedulers that understand, the proximity of the systems to each other so that you can put your workload in the right place and get kind of the expected performance and throughput.
I think adding to that, when we start to expand out from this specific hardware infrastructure, we're also starting to look at what are all the surrounding systems that are necessary for cloud service providers to be effective. The big players out there like NVIDIA have very specific reference architectures, but they leave the delivery of multi-tenancy, multi-cluster setups to the vendors. They don't provide that themselves. So one of the areas which we're trying to really focus on is how can cloud providers provide those services and all the supporting services, the DNSs, the identity management. It's a much broader problem just making and providing access to GPUs and to the networking to support that GPUs. It's the whole ecosystem around it so that cloud service providers can sell access to those GPUs, that they can provision Kubernetes clusters on demand with the right setup from the beginning. I think there's also a major day one challenge. There is so much complexity in this infrastructure. And as Randy pointed out, there is so much that's interconnected, that all these dependencies between RDMA networking, NVIDIA's NVLink, as well as potentially InfiniBand and slightly older architectures. Then throw in the fact that you've got to be able to group GPUs, potential GPU slicing. All of this means that quite often this hardware is delivered, racked, and stacked, and then it can take months to sometimes years to get this hardware actually viable and working. And so as part of the reference, what we're also looking at is how do we distill that into a opinionated, albeit deployable out-of-the-box solution to help organizations get started faster and to potentially identify any gaps that they may have in the way that they're looking at their architecture from day one. Obviously, we're focused heavily on our Cordant product within the architecture, and Cordant gives us that ability to capture that reference in code and deliver that, but then providing people that ability to swap out the parts as needed. And so that's become a key part of why we shared such a detailed reference and why we'll continue to share it.